There are many cases, specifically with respect to the plain text file as well as binary file, where the data is flowing from one location to another, and you have to handle that all of that flow of the data. Okay, database tables are okay, but when it comes to various unstructured data, it becomes very important to define the flows. Okay, so Flume is one such application. Flume was specifically designed for handling the logs in Hadoop, or handling the logs of your web server. Okay, so it started with handling the logs of your Apache web server, because whenever you run these websites, you have more than one servers running the running the running your web application, and parallelly they keep generating these logs. You want to move this log frequently to your HDFS, or you are running crawlers which are downloading data from Twitter and other sources. You want to move this data as and when it comes to your to your HDFS or Hive or wherever you want to move onto, I mean, whether HDFS or any other way, wherever you want to move, you will have to do it just like the way you do tail minus f. Tail minus f, as and when the data comes to the file, it displays it to the screen, right? So those kind of things are very smoothly done in Flume. Okay, so Flume can be used as two examples I gave. First one, to handle your web apps data, you have multiple web application servers running, generating logs, and you need to move their logs very fast speed onto a central machine, onto HDFS, not central machine, onto HDFS. Second example I gave is that you want to do a sentiment analysis and you want to download using crawlers various data from Twitter and then move this data to HDFS. Okay, what do we mean by log? Okay, so whenever we run an application, it basically creates the errors and various debugging information, and all of this information is saved into this file continuously. Okay, so this saving of the file, saving of all the error messages, is called log generation. Okay, a log generation can be uh, in the form of files. A log generation can be in the form of devices, where in case of Unix, you have specific devices called varlog and vartmp. Okay, and probably all languages, be C sharp, be every language provides you mechanisms to generate logs, or at least library. Every language has got libraries to safely manage the logs of your application. All right, databases has logs, right, Cletus? Okay, good. So the way, the basic philosophy of Flume is like this: you create various agents, agent 1, agent 2, agent 3. Now each agent has got three things. First is source. Source is somebody who generates the data. Okay, and second is channel. Okay, let me talk about channel a bit later. So agent has got one thing called source, other thing called sink. Sink is the final destination of the data. All right. And the channel is the memory supported queue, right? Now, every agent has these three things, and these three things are connected back and forth. Okay. So source knows that this is my channel. So source puts all its data into the channel, and sync knows that this is my channel, and sync reads from the channel. Okay. And in case sync is too fast at generating the data, it will have to wait a bit if the channel gets full. Okay. So if the channel gets full, basically channel is a memory supported queue. On one end, source keeps on pushing the data into channel, while sync keeps on reading in the bulk and pushing it somewhere else. Okay. So in case sync is slow and source is faster, the the channel will get full very quickly. And in case source is slower and sync is faster, channel will go empty. Okay. Now this is what we call an agent, right? So there is something called source which generates the data, right? Well, who can be a source? Say a source could be tail minus f. What does a tail minus f do? It reads a file continuously. Okay. Or it could be a daemon, it could be a process running at a particular port, listening for the input packets to come in. Okay, that is source. So a source is something which generates you the data, right? So let's say we figure out or let's say we launch a small services on multiple machines. Okay, and we define that all everywhere we are running 1111 port on say 4444 or 44444 port. Everybody who generates the log connects to this source and puts the data there. That is my source. Now from that source will take the data, push it to the channel. Now, sync is continuously listening on the channel and will keep on reading from the channel and push it to whatever we have defined. Whatever kind of sync it will push the data to that place. Okay. Sync might be sync might be dumping the data to any other agent's source. Okay. Sync might be dumping the data to anybody else's source, which means you can chain the agents together. Which means you can chain the agents together to ensure your delivery of the logs to the final destination. All right. So Flume is essentially a distributed, reliable, and available system, and it is designed for collecting, aggregating, and moving large logs from many different places to a central data store. Okay. Now, so Flume supports a large variety of sources. Source is the data generation guy. It could be the data generation could be based on syslog daemon of Unix. Syslog daemon of the Unix has been the standard, and lots of people follow that design, where there is a daemon running, there is a process listening for the logs, and the whole system gives all the error messages or all the error logs to this central daemon or process, and it keeps on storing it whatever way we have configured it to. All right. So source could be syslog, which means if you want to gather the system logs of all the kinds of every system running you're running your machines, it will be very handy to create a source which handles syslogs. Okay, and it could be log4j. Okay, which means if we create a log4j kind of a service, it will basically help you to gather logs from various kinds of servers, such as all those who support log4j. Okay, the way you have log4net library, open source library, to generate to create logs in .NET. Similarly, log4j is there for Java and other multiple languages. So earlier there was syslog. Java guys thought that they will try to replicate a similar design by creating log4j and then log4net and so on. Okay, so the design has become a de facto where logging is basically a daemon. Okay, now that's about the sources. Flume nodes can be arranged in arbitrary topologies. Okay, which means we can have multiple sources putting the data into a channel, and we could have sync pushing the data to anybody else's source, which means we can chain them together. I'm sorry. Right? So typically in general there would be one agent running on each source machine with tiers of aggregating nodes that the data flows through on its way to HDFS. Okay, so the data goes to source puts the data into channel sync pulls the data or sucks the data and pushes it into HDFS, or maybe pushing the data to another source, and would be there will be a full chain. Okay, the important thing you should notice here is every agent has got a direction. Okay, input and output. Okay, which means every agent has got direction, and therefore they all target to reach to some point. There is a flow in a certain direction. Now let me just take an example that will be a better way to describe. And there are two kinds of delivery reliabilities. One is best effort delivery. Okay, it doesn't tolerate the node failure. Okay, and then there is another delivery reliability which guarantees deliver in node failures. Those are the two designs. Now let me take an example. You can also download it. So since those who I have given my PDF, they might be having an older version. Now in some time they will have the newer version. Okay. All right. All right. So let's try to do a Flume thing once. Okay. Now I have created already Asgiri, and then I have got Flume. Okay. Under this, we have got conf directory. All right. So let me walk through this Flume properties. What does it have? So A1 is my agent name. Okay, for the example sake, A1 has got sources, sink, and channel. Right? The name of its source is R1. We could put comma R2, comma R3, comma R4. Okay. Similarly, we could put sinks, one sink, two sink, three sink, and so on. And channel is C1, and mostly the channel is generally one. Okay, you can also have multiple channels if you wish so, but mostly you will find only a single channel. Okay, so sometimes you might want to have a channel which is there in memory, and there is another channel C2 containing a mirror image of the data on the disk. Okay, so if sync fails to read from C1, it will start reading from C2 and try to get the data. Okay, now we just gave it a name. We told agent A1 that the name of your sources are these are your sync, and these are your channels. So that is first definition of agent. Now we want to describe what is each one of that. So what we say is R1's type. R1 is what? My first source. R1 dot type is netcat, and R1 binds on localhost. R1 binds on this port. Okay. So those who do not know what is netcat, you can think of it as a very quick way to create a daemon service, very quick way to create a process that listens on a certain port, so this netcat is essentially reading the data from localhost by listening on localhost at 44,444. Okay, now next is that you describe your sync. So I say my here I have defined the sync name as this. Okay, while other names are 2 characters, this one is particularly bigger, and I say that sync dot type is, this one is commented. Note that this is hash commented. Okay, so sync one type is HDFS, because what we are trying to do is we are trying to listen on the local host at a particular port, and whatever data we read from there, we are going to push it onto HDFS. Okay, we are going to push that data into HDFS. All right, now, and when we say type is HDFS, we need to tell that where, in what folder should it be putting the data. Okay, in what folder should it be putting the data. Now we described the sync, we described our source. Now let's describe our channel. Channel's type is memory. Okay, channel's capacity is 1000 bytes. Okay, and transaction capacity is something. All right, now once we have described these three things, we also need to tell our sources that your channel is here, our sync, this sync, that your channel is this. So agent need to know about its sync, source and channel, and source needs to know about, as you can see in this diagram, so agent needs to know about all the three people. That's what we have defined in the first section here. Okay, now we defined source, we defined all these three, and the fifth section actually, not fourth, defines that, tells the source that put your data into this channel, tells the sync read your data from this channel. That's all. Okay, all right, let's start. So once you are done with it, you run your Flume ng agent, defining a config directory. Okay, it says that the specified configuration file doesn't exist. All right, now, so me just all right. So Flume agent says, let me just fix some formatting issues. Okay, so you go here. So we have got Flume agent. So this is the command to start. We created the configuration file. That was the 0 step. This is our 0 step. Okay, and okay, step 0. We created the config file. Step 1 is start the agent. Now let's see. Okay. I need to define the folder also. The folder name is conf. Okay. Folder name is alright. Now if it runs properly, that means it has started the service called netcat, which is listening on the local host 44,000. And how do you test if something is running on a particular port? Anybody? Quickly. If I ask you that, can you test if it is really running on 44,444 port on the local host, what will you do? Anybody quickly? Netstat. Okay. Anybody else? Netstat is good. And if you want to communicate to this service, what you do? So PSEF is good, Netstat is good to just find out if the process is running on a particular port. But if you have to talk to this service, what will you do? Yes, Telnet. Okay. Thank you, Sanjay. Thank you, Shrikant. So what you do is Telnet localhost. All right. So it says, sorry, I'm on my Mac, local Mac, and let's just log in onto Hadoop one. All right. Now say telnet localhost, and I say, all right. Now it is connected. You can see that if I do it on another port, I'll get say error. It says connection refused, which means, or if I just close this service and try to connect again, it'll say connection refused, which means ours is the service which is basically listening on this port. All right. See, so it's running fine. And whenever we say, hi, how are you? So you will see that the data is getting created parallelly into our HDFS file. Okay. So HDFS file, the configuration we had on this machine was essentially creating a sync. It says sync, and does it say creating this particular temporary file as Giri Flume web data. This is where it is putting our data. Okay, so it says as Giri, and Flume and web data. You can see that. And as in when we can delete this, we can delete these files. And as in when we talk to this service, again, hey, what's up? We are just fiddling around. Okay. Now it'll again create one more file. Let me refresh. Okay. So this is where it is dumping the data. All right. Hey, what's up? We are just fiddling around. It's just that it has put the data into a format called Apache byte writable. Okay. So it has to be read using this reader, specifically if you're reading from a code. So we were successfully able to communicate to this daemon, which pushed its data to HDFS. Okay. Now instead of this, there could be hundreds of kinds of syncs available, and and you can have a look at those all available syncs here. Okay, you can have a look at the syncs available at here. So there are multiple kinds of syncs, and most importantly and most neat one you will like is tail. Okay, you could define your tail, your source as type exec, the way we defined our source as type exec, and you can define that this is my command line. All right, it will execute this command on all of the nodes which are running your Flume and push it to your sync whatever you want to. Okay, sounds good to you? All right. Right. So Sanjay, as I was telling, so that example I have not prepared, but I am in the middle of it. So Flume, you will feel the real requirement of Flume in the cases where you are continuously downloading data from, say, from Twitter. Okay, so Twitter provides you an API to download a sample of the total data, and as and when the data arrives to you, you want to push it to the HDFS. Okay, there you will feel the need of a system like Flume. Okay, so that's basically when we do sentiment analysis, we generally download the data from Twitter, and that day there's one example I'll be sharing with you where I'll demonstrate how to download the data for doing sentiment analysis. All right, so that is another use case you can try it out, but there are infinitely many use cases, and and this kind of Flume kind of system can be used with or without HDFS. Almost in every large organization or organization which has consumer facing services, you need to have a centralized place where all the logs need to be moved continuously, so that the people who are developers, administrators, they have a single place to look for the data rather than rummaging around hundreds of SSH servers. So, Cletus, I was talking about the sentiment analysis. We'll talk about it in a minute. Don't worry about it. So when you talked about log4j, can it be configured? Yes, it can be configured to directly send the data to Flume's agents. Or Flume's agent can behave like a source to log4j. Okay. So when you're configuring log4j, you can just mention this server and then it will start accepting the log4j logs.